So good evening, class.
Good evening. Good evening, sir.
So how are you doing?
You're going good.
So actually today, I think everybody is in class because if I look at the attendance register, I'm seeing that you are almost the number that I needed to teach. I think if there is nobody, he'll have to consult you for the notes. So last week we talked about alkanes, alkenes. So, but today we want to continue with a new topic, that is alcohols. So now I know that if you have got the knowledge about the hydrocarbons, you can be able to know more about the alkanols, because they are just having the same, they are just in the same series. Only that there is we have got some things that will be adding on the same. Now, I know that for us to continue, we must have the objectives of our lesson. And for that reason, I want you to capture this down. So what we want to know about these alkanols, we want to define alkanols. Then after defining alkanols, a way to see the nomenclature or the naming of alkanols. How can we name alkanols? Then we will go straight away and see how we can prepare some of the alkanols in the laboratory. Now, so I think you can be able to view the screen. Are you able to see my screen?
Yes.
Now, so let us start by defining what alkanols are. So I want anybody who can volunteer and define for us this term alkanols. Yes, Evelyn?
Alkanols are compounds made up of carbon, hydrogen, and oxygen.
So actually that is absolutely right. Alkanols, these are compounds or a class of organic compounds which contain carbon, hydrogen, and oxygen as the only elements. So as we know that they have a general formula of CnH2n plus 1 OH, where n is any number. And if you observe well on your screen, you can be able to see that formula that we can use to do what? To know that particular alcohols. Now, the second objective that we have concerning our course or our topic is all about nomenclature or naming of alkanols. Just the way we named the other hydrocarbons, that is the same procedure we are going to use when naming alkanols. So as you can be able to see on your screen, we've said that the first thing that you need to do, you need to select the longest continuous chain to which the hydroxyl group is directly attached. Then you change the name of the alkane corresponding to chain by dropping the final E and adding the suffix OL. So that is the first procedure that you need to do when you're naming alkanols. So what can we say about the next procedure? What is the next procedure of naming alkanols? Mercy?
You identify, you name the longest chain. After identifying the longest, you name.
That is right, but there is something that you've missed. After selecting the longest chain, the next thing you need to number the longest continuous carbon chain. So you need to number that chain that contains the hydroxyl group. So that is the next thing, but that is a very good trial. Then the next procedure that we should do, or the next step that we should do, yes, Evelyn?
The third is to determine the position number and the type of the.
Exactly. Determine the position or indicate the position of another substituent and prefix by using numbers corresponding to their position along the carbon chain as locans. So that is the exact thing that you need to do. and I think you can be able to see that on your screen. Now, and maybe if I can give the last one, during naming, isomerism must be put into consideration, whereby we know that alkanols do exhibit two types of isomerism. According to your screen, you can see that you have positional isomerism and branching isomerism. So, under position isomerism, the position of functional group OH varies within the carbon chain. For instance, when OH group is attached to the first carbon atom, the molecular structure can be represented as, that is CCCOH. And if you can observe well on your screen, we have got OH that has been attached to the carbon, the first carbon, when you start naming from the right hand side. And for that reason, the name of that compound is referred to as propan 1-ol. Or in other circumstances, you can name it as 1-propanol. 1-propanol. Now, then when the OH group is attached to the second carbon atom, the molecular structure will be 2-propanol or propan 2-ol. I think that you can be able to observe that from your screen. Are you able to see my screen?
Yes. Yes.
Then let's go to the next type of isomerism, that is the branching isomerism. So the molecular formula of the compound remains the same, that is in branching isomerism. However, there is a rearrangement of carbon atoms such that one or more carbon atoms from the molecule form alkyl groups attached to the longest carbon chain. So from that explanation of the branching of isomerism, you can be able to see on your screen, we have got pentanol, that is 1-pentanol, the structure of 1-pentanol. Then we have got the structure of 2-methylbutane 1-ol. Then there's the other structures is the structure of 2,2-dimethyl propan 1-ol. And the fourth structure is 3-methyl butane or butane 1-ol. So that is the structure that you can be able to see that on your screen. Now, the next objective, I think that it will be the last one for today's lesson. That is all about preparation of alkanols. So, apart from this, the one that we are seeing here, whereby ethanol is being prepared from decomposition of glucose molecules in the presence of enzyme, according to the equation that you can be able to see that. I want you to tell me the other method that we can use to prepare, what? Ethanol. So, any volunteer who can give us another method that can be used to prepare ethanol?
Yes, hydrolysis of sodium hydroxide.
Absolutely right. That is a good method that we normally use to prepare ethanol. That is hydrolysis of sodium hydroxide, whereby you do what? You hydrolyze sodium hydroxide and you'll find yourself remaining with what? You'll find yourself remaining with your alcohol. Then, do we have anybody who can be able to give us another method of preparing of alcohols? Anyway, before that, I want to give you another method. I think this one you've never heard it. We have another method that is called oxymercuration dematuration of alcohols, of oxymercuration dematuration of alkyl alkenes. So that is also another method that we can use to do what? To prepare alcohols. So I think you will have to research more about on the preparation of alcohols and more on the methods. But for today, I want us to reach there. Then we will have to meet in the next lesson. So I think you can be able to define alcohols. Any definition on alcohols?
Yes.
What is alcohols?
alcohols are compounds that is made up of carbon, hydrogen, and oxygen only.
Absolute right. So that is the definition of alcohols, and of course we've talked about nomenclature whereby you name the longest chain, you number the longest chain, then and so on and so forth. So I want you to do this assignment for the next class, then you will have to present during your next class. Now I want you to give me other methods apart from the ones I've given you that can be used to prepare alcohols. So let's stop from there, and may you have a nice day.
You too.